Cool.
My name is Toyotaro Suzumura. I'm just.
That's nice for finger working idea.
My name is just the Toyo Suzumura. Just the and I myself and also the Koji Ueno, my student, is just working on this benchmark. And then before just jumping in the result of this the solid list. So last week we went to the conference called IISWC. I think yes you know that. So then we just published a paper called this title. We just analyzed the different implementation provided by the Graph500. So then we just just show the performance analysis on the Tsubame 2.0. So then I think as you know the Tsubame 2.0 is characterized by having lots of GPUs. Now is this supercomputer is 5 rank supercomputers, and it's very energy efficiency. Anyway, it's just introducing myself. But I work for the university as well. But I also the researcher and IBM research as well. And anyway, so Tsubame 2.0 is the system configuration as this is illustrated as follows. This is a little bit small. So if you jump into the detail of the specification, the CPU is an Intel Westmere EP, and RAM, and we have 56 gigabytes for the memory, and there is around 1,400 nodes, and the network topology has infinite network and full bisection fast tree topology, and also the GPU. We have lots of GPUs, and one node has 3 GPUs per node. But but this benchmark we didn't use the GPUs. Well, I got a question from Richard Murphy, but did you use the GPU? But we didn't use that. But maybe it's going to be next time. I don't know. But for the MPI versions, we use the Impact Beach instead of PMP. Just to compare the performance advantage of the Impact Beach. So then, if you just go to the paper of the IISFC, the difference implementation has kind of like lack of scalability on distributed memory environment. So this is kind of weak scaling performance comparison. So then this is just a little bit with a small environment from 1 node to up to the 60 nodes, but this caps is just is decreasing like this one. So we just decided to jump into this ranking from this, and then we just started to implement that one. And my student Koji Ueno has contributed a lot to the implementation, and also that we just, as I think you already know, that there is a 2D based partitioning method provided by proposed by the Andy Yu, Lawrence Livermore National Lab. And then our implementation is based on 2D partitioning. And then this result is that, as you can see, left side is comparison of our optimization. And then 3 bottom simple and replicated CSR and replicated CSC is difference implementation provided by Graph500. So then, so since we have like a 1,000 nodes, just one 1,000 nodes, so then it should be scalable. So then TAPS, this is kind of like a premium result, but this is our optimized implementation shows linear scalability as shown in this slide. So then, as I mentioned, I think the first and the second the team has method of 2D partitioning, but we also just use the 2D partitioning, but we also did that optimized implementation of the especially the fault pay phase with asynchronous communication And also the data compression techniques achieves is contributes a lot of the high scalability and the high scores. And also we also did robotic sorting. Just the caring about the Graph500 has used scale.
I'm not sorting vertex, I'm lazy.
So that's our set of our optimization strategy.
I have no clue.
So
we're out of time. Next speaker.
Okay, sorry. Okay, so just the discussion item is the so I think it's just I'm gonna just conclude that, but I want to just discuss the I think ranking method is important, but we just for example the Tsubame in the Tsubame case we just allocated just only 13 hours to did the experiments. We just didn't just run it like for the whole weeks and something. But validation phase and BFS, we have to do this 16 4 times iterations. So that takes a lot of time. So 7 hours, 6 hours something. So then I would like to suggest that the reduce it from 64 to the smaller numbers. So that's what it just in anyways, so this number it just shows like our optimization of the validation phase, but we did that kind of optimization. So anyway, thank you so much for all the relevant people, including Satoshi Matsuoka and other Aoki and other members, press members.
Thank you for the hybrid.
Thank you for
the cells.
Yeah, thank you.
Thank you.